Last notes, what we talked about, approximating how do you round decimal places, significant figures. We then talked about, okay, when we round, we're now no longer in the exact, we're no longer talking about the exact number. We're talking about a number that's been approximated. So not true, but near the truth. And so we talked about learned about bounds. The bounds are then this neighborhood of numbers that say, okay, well, now that we've rounded in this neighborhood of numbers, somewhere lies the exact number that we want to talk about. But with any approximation that we have, there's some element of an error that we are bringing into this equation, to this situation, to this problem. So when we start talking about error, we're going to start talking about percentage error. Now, percentage error is something that pops up a lot in a lot of IB questions. So I would maybe put a star here and say very common IB question. A lot of times an IB question will be like, okay, we're going to ask you to do X, Y, and Z. And at the very bottom, they're like, find the percentage error of this. It's a very common last question thing, which is actually a very easy question. So it's an easy point because this formula is in your formula packet. So I would like for you to go to Schoology, go to Classroom Information, and on Classroom Information, you'll see that there is a formula book or formula packet. You should be so familiar with this formula packet by the time you take your IB exam in 2 years that you will know exactly where this percentage error formula is. So you'll be asked to find it, and you're like, oh, that's something that's in my formula packet, and go. It is on page 3 of your formula packet at the very, very bottom. So go ahead and try and go find it, take a note, and look at what it says. This is what it says. This fancy E is for percentage error. And here's the formula. It says VA minus VE all over VE. Then it has these fancy brackets around it called the absolute value. It just means that we're taking the positive value. Your percentage error will always be positive. You don't necessarily have to take the absolute value in your calculator. You could just know, oh, I just know that this always has to be positive. Now this is going to give you a decimal that is, for the most part, very, very small. And since we're talking about percentage, we want to multiply this by 100. So we're going to take our decimal, multiply it by 100 to give us a percent, right? Because 0.4 is 40%. 0.04, so 0.4 is 40%. 0.04 is 4%, right? And how we convert from the decimal to the percentage is that we have to multiply by 100. So this is going to give us a decimal. We multiply by 100 to turn it into a percent because it's percentage error. Now, what are these pieces right here? VA is your approximate value. What that means is this the value that we guessed, or the value that we rounded, or the value that we are using to represent, right? The VE is V exact. It's our exact value. No rounding, no approximation. You have to put the exact value of what it is. Now, it could also be the true value, or the non-rounded value. Okay, so all of that, let's put it into action because it's so hard to see a definition without actually understanding what it means or seeing it in action. So we have a fraction, 22 over 7, and it is often used as an approximation of pi. So how close, in other words, how many decimal places does 22 out of 7 approximate pi? So we're going to look at what is pi and what is 22 over 7 as decimals and figure out, well, where around does it stop being the same? So if you're going to take your calculator, go do 22 over 7 and find that decimal. Write it to a few decimal places. Go ahead and do pi and plug it into your calculator. If you don't know how to turn your exact into a decimal, if you do 22 divided by 7 and click Control Enter. Notice the double squiggles here. The double squiggles above Enter means approximate anyway. If you're like, oh, it's approximately that, right? So it's saying, hey, give it to me as a decimal. So if you keep getting fractions back as your answer and you want it as a decimal, that's how you change it. So there's your decimal right there. Pi. Pi is right here. So if you click next to H, pi, you can see you have a bunch of options. You can see your imaginary number is there. E, which is also a cool weird number, is there. But you click on pi and you press enter, and then it will give you what pi is with a certain amount of decimal places. 3.1415926, etc., etc. Okay, so now we want to know how many decimal places does it exactly round it to. So where are they the same to? 3 is the same, 1 is the same, 4 is the same. At 2 here and 1 here is when they start to differ. So it is approximated to the second decimal place. So to 2 decimal places, it is the same. After that, it is no longer an accurate approximation. And then it says, find the percentage of this approximation, giving your answers to 2 decimal places. So we're going to find our percentage error. The first thing you should do is write down your formula, always. Your formula is like your recipe, right? So you write it out. You're like, oh, I know that I'm supposed to find the percentage error of this situation. I know that there's a formula that goes with that. So write it down. This is a recipe because it gives you ingredients that you need to bring into this meal, this problem, right? So it says, okay, you need a VA and VE. Those are the variables that are in this situation. So you need to go back and find, okay, well, what is VA? What is VE? And it says up at the top that the fraction 22/7 is often used as an approximation of pi. So our approximate value is 22/7. Do not use the decimal here. You have to use the fraction 22/7. Okay, so you need to make sure that you're using that exact value when you're talking about the approximate value. Same with the exact value. The exact value here is pi. Pi is the only way to write pi to the exact. If you round it, if you stop it, if you write it as a decimal or a fraction or anything like that, it is not actually true. It's not exact. So the only way to write the exact value of pi is the symbol pi. All right, we have our formula. We have our variables figured out. We have planned this problem. You should always have a plan step of writing all of this out before you even start. It's a great way to calm your nerves, center your focus, and get started on a problem. So here we've got all of our information. We're going to start solving. So I know that I have to do the absolute value of V approximate. So I take 22/7 minus V exact divided by V exact, and then multiply by 100. Plugging this into your calculator, I'm going to do 22 divided by 7 minus pi. I'm going to put those guys in parentheses because then I want to divide by pi. Notice here that we have an E here. We'll talk about this in our next lesson. When you see an E in your calculator, it means it's in scientific notation. That's times 10 to the -4. If you remember what that means, it means it's a really small number. It means this decimal needs to move this way 4 times in order for it to become the accurate number of what we're talking about here. So that's fine. That's part of our formula. We still need to finish our formula, which is to multiply by 100. Now that we've multiplied by 100, notice the E is gone, and all we are left with is this. And it looks like a decimal, but in fact, it is the percent. It's 0.04%, because we did multiply by 100 after finding that error. So 0.04% is the percentage error, which is a pretty minuscule error to have. So it's a pretty good approximation, which is why it's often used as an approximation. Okay, example 7. This one's a little bit tough because it's hard to understand what the IB is asking here. And that's almost always going to be the thing that you struggle with the most in this class is what does this problem actually want me to do? And so that's what we're trying and striving to solve in all of our IB problems is to figure out what are they asking me to do. So let's read through it and I'll explain to you some of the words that we can kind of figure out what's going on. A runner's time to complete a 100-meter sprint is taken using two devices. The first timer measures a time, T1, to be 11.5 correct to 0.1 seconds. This is already numbers, this is already information. And part of our planning process, right, up here we had a plan, and then we had a solve. So as a part of our planning process,